Hey, one sec. I gotta open.
I'm Tim Heath. This is Matthew O'Gorman. We're going to talk to you today about free hardware.
Woo!
Woo! There's contact info. Hooray.
Oh, you're moving. Heck along.
Warning, Mog is a certified freetard. A portion of this talk related to freedom.
It's a big deal.
Deal with it. So what is this free hardware of which you speak?
That's an excellent question, Tim.
Are we giving shit away for free? All that work?
No.
No.
It's free as in freedom, not free as in beer that I am drinking.
So what does that mean, commie?
You're moving way too fast on me.
Well, if you've got more to say, say it.
Okay. There are four types of hardware that are being produced really today. The first most common is closed hardware. That's stuff that comes to you in a black box, and you are allowed to use it in the way that the manufacturer intended you to use it. Good examples of this are like DVD players that don't let you fast forward, cars that have rate limiters, defibrillators that don't just let you kill people randomly. There's lots of good things, lots of bad things. It's just what it is. So, iPhones, yeah, that's pretty close.
Well, that's also our second.
Right. The next I would say is hackable hardware. It's stuff that was designed to be closed, but for either mistakes of the manufacturer or willfulness, you're allowed to go in and mess with it to some degree. I would say most computers fall under that. You can do a lot with your computer. Right. Cell phones, most of them you can modify to do things you want them to do.
Root them and whatnot.
Xbox, Dreamcast, Wii, lots of video game systems have the ability to run your own code on them and do what you want to do to a large degree. But the actual physical hardware is still very closed. You aren't allowed to see the schematics for the hardware. You aren't allowed to easily modify it. Generally, it's just not as fun. The next thing on the list that most people would consider the pinnacle is open source hardware. And that would be things like the Arduino, RepRaps, Bus Pirates, the Chumby, and
it's a growing field.
Right. Yeah. And those things are all free. They distribute the schematics, the Gerbers, design documents in an open format. The license allows you to create it yourself, modify it, do pretty much whatever you want with it. Grant you the four freedoms that are in the free software side. But the problem with a lot of the open source hardware and what differentiates it from what I would call free hardware is open source hardware tends to be made with proprietary tools still. The majority of it, I would say, being made with Eagle, which is released under a freemium model where you can design circuit boards, 4 layers up to 2.5 inches squared or 4 inches squared.
Yeah.
Whatever's just a little bit bigger than the Arduino.
Right.
And that's why the Arduino is that size. And so, why does any of this matter? Because freedom matters. Big deal to me.
No, really, why does it matter?
No, screw you, freedom matters. I like the Matrix line, what good is a phone call if you can't speak? The fact that these open source hardware devices are made using proprietary software means that even if you have the tools, you can only speak in the vocabulary the tools allow you to speak in, and you can only share them with other people who have enslaved themselves in the same way you have, that have bought into this program. And that's bad. Right. Strong words. And so, yeah, that's the big things are the extensibility. So a lot of the free tools, for example, have very, very varied workflows that you can do, and you can do whatever you want, and lots of cool stuff. And then the other thing is just the freemium limitations of all of the. There are the biggest one being Eagle, but there are also some other free PCB editors. And the other common limitation is you can only produce boards with their board house. There's a popular tool. I think it's called Free PCB, and it has a nice little editor and has all these circuit testing stuffs, but it doesn't actually give you Gerbers at the end of the day. you can only produce them with that one board house. Then it's not free PCB that I'm thinking of.
There
I'm
are
sorry.
services that do it. We don't use them, so pardon us if we don't know.
Is that the one?
Yes, that could be.
I can't remember
PCB
which
Express.
company it is. I just really disliked it, and I did not look further. Sorry. And so that's that stuff. And so I'm done ranting about freedom. Y'all, I hope the talk was much longer about how I hate lack of freedom. And we were actually going to get more into the actual design of electronics in this version.
Right.
And so
we make stuff. Step one. Steal underpants. Step two. No. Step one. You have a need that you want to fill. You have a product that you want to build. In one case, let's say an amplifier. So you start learning some of that. Step two, you research. You say, what do I need to build that amplifier? What do I need to do this?
Look at other people's
some
schematics.
people will have fancy double E degrees. Some people are just hobbyists who pick up a couple books. But you teach yourself what you need to put into it, what you build it with. Step three, you start sourcing those components so that you have like little amplifier chips or whatnot. They make some integrated circuit options. They make other, or if you've looked up, you want to build a certain type of transistor amplifier. You want to know what those parts are. Now you're going to get a bunch of those parts in. They're really cheap. Buy a couple. You can get them from Radio Shack, Mouser, SparkFun. We didn't say DigiKey, but I'm going to say DigiKey.
Def DigiKey. But back to that. Yeah. So it's not just necessarily small components like resistors, capacitors, or ICs that will do your amplification. Other projects, for example, that we've done, we've used AVRs extensively. And so one of the nice things about the free hardware movement at this point is you can get lots of modules that do a lot of what you want to do already. And that's why I was listing SparkFun, not so much for their components, because their component prices are ridiculously high because they're SparkFun.
Right, but all your Arduinos and some of the shields for
breakout boards
that's all
and
intended to be prototyping material. You've got something you can write software for and then build a product out of.
And so you can skip some of your steps at first and just take someone's working circuit, because it's a free circuit that you can then go modify and do something else. But you can get that, you can bootstrap your project and skip some steps, which can be helpful.
And then sort of in step 4, then you're actually going to, put it in, build a working prototype, so that lets you tweak values, that lets you know that you're on the right track, that lets you know that what the circuit that you're going to end up with is actually going to work, which is an important step sometimes. Because at step 5, you get a lot of frustration trying to make something work. It's not going to be right away.
Burn up components. Because the components are cheap, but messing up and blurring out a $3 IC is not fun.
Right.
It is very annoying.
Step 6.
So step 6, you eventually get it to work, and that's great. And then from this step is really where you start actually using the software. At this point, I would say it's far easier just to do all this prototyping on paper and just hands-on, looking at chips and building little project boards. But from this point on, you are going to see some benefit in actually building the project in the software. And so this is where Geda comes in. Geda stands for GPL, Electronic Design Automation. It is a set of tools from starting from scratch to building a working board. It has simulation tools for doing electrical analysis. It has schematics, PCB layout, Gerber viewing, lots of it has FPGA simulation if that's something you need. It has lots and lots of tools. We pretty much use just their schematics and PCB layout tools, and their Gerber viewing tools. They have some nice stuff. You gotta pull up. So the first thing, it's gotta go. You gotta go leave full screen mode. Just double tap.
So here is the first one is Gscheme, which allows you to create schematics. You're going to define your parts, define your passives, make connections. This defines the circuit electronically. You're then going to be able to import that data that you've just defined into, I didn't pre-open this. Woo! Doing it live. Load layout. Mark, talk. You do this more than I do.
I know, because you don't ever organize your files. So Gscheme has lots of built-in tools, symbols by default. So the resistors, the LEDs, etc., are all built in just from the scratch. But some of the parts you actually build yourself,
Right.
and it's pretty easy. You just draw on the program. So like this connector here, I think I made that at some point, and you can just draw it. The purpose of the schematic, if people don't know, is it's used mostly to verify your design to yourself, because this is a very simple board that we made. This is the dice, right? I can't see it
Yes,
here.
it is actually.
This is the dice board we made. It has just, I think, 160 connections. So it's really not that many, but making sure that all of them are routed correctly when you do the board can be very frustrating. And so what this tool does, at the end of it, you can export this information into the PCB program to build a net list. And it will tell you if your connections are correct or if you have shorted a wire somewhere.
Right. And so within Geda, the programs, the binaries are separated out, but it gives you separated workflow kind of input-output path from each program. So the next one it's called PCB, which is easy, but it's part of the Geda tool set to get it specific. When you talk to somebody, it's like, what design software do you use? I use PCB. No, what design software do you use?
Yeah, it's a horrible name.
But so again, you can see now we're actually going to define the physical world. We've got the edge of our board. We've got all the traces and connections, vias if they go through the board, or other pins and holes for anything else that you're connecting, pads. Okay, I don't auto layout, although this program does have it available.
Yeah, and it's actually really useful, even if Tim doesn't like it. It has great ability for you to select just a few rats, and it will build the auto layout.
Sure.
And then you can go delete and do what you want. And the other nice thing about it is it doesn't have actually a layer limit. And so for just giggles, for example, you can give it a horrible board and say auto layout, and it will go 20 layers
20
deep,
layers, yeah.
and it will find a path in a very dense board, but it'll make it happen. But it's pretty cool.
Yeah.
This is PCB, and it's part of Geda.
Geda, yeah, you want to look up Geda. But yeah, you go through this. This gives you the ability to route. It gives you the ability to define traces, define layers, define all of that data that defines the physical world and the board. You can also, there is
Design rule checks.
Design rule checks, DRC. Yeah, DRC check, which is, it's just going to make sure that what you just created fits the standards of your board house. They say they can't mill something smaller than 6 mils in distance, then you need to know that, hey, you've got these things too close here or too far apart there. And it kind of lets you work that way and work out kinks before you even send it to the board house, which will be the next thing. Back to this.
No, do that and then hit start presentation, I think.
Oh, you're right. Whee! Okay.
So yeah, these are the two big
So
things.
PCB
PCB.
and Gscheme. We've just
Right, we just talked about this.
Sorry.
So the symbol creation is making your own parts that don't exist in the system. So simple things like resistors, caps, even some chips like Atmega chips are in PCB or in Gscheme by default. But more complicated things like random ICs aren't going to be in there, and you'll have to design your own symbol to line it up correctly. And then the schematic design is what y'all were seeing a picture of. And it also has the ability to verify design. You can stress power pins and stuff and demand that symbols have grounds, and it'll say this was never routed to ground. So if you had gone straight to PCB and not noticed that, you would have a device that wouldn't work. And so it can catch some things like that for you.
Under PCB, you can create the footprint, which is the pads that your product's going to lie on, for like an Atmega chip or even just your transistors. The footprint, again, the physical world that that defines the layout for, then the layout for the whole board. So you can, you're going to make a footprint, and if you're for a transistor, and then if you're going to have 25 transistors on there, you can just copy that one footprint. So that's a lot easier. You route the traces together. We've talked about this, DRC checks. Pretty renders. We do get there's a lot of push in some of the other EDAs and stuff that will output, kind of what your board will look like when it's done. And so that's fun. And so we've done all that design work. We've sweated. We've labored. And step 8, we send it to China.
This step
For
is
freedom.
right
Yes.
for freedom. This step is of course optional. There are ways to make boards in America. They are expensive, and yeah, China is cheap and nice, and so there are board houses. Our preferred board house is Hackvanna. It's a guy on IRC who. I was in the Pound PCB chat room one day, and I was talking about a board I was doing, and he said, "Hey, I have a board house in China. Send me your design files." And ever since, we've had a good relationship. He's made a couple boards for us. He's really cheap, really nice guy. And the nice thing about him is it's really just this guy, and he speaks English and will talk with you and make sure that your board will come out of the factory correctly. My one complaint, the other board manufacturer I'd recommend is Seed Studios. They do board building for you, but they have a problem with language between you and the actual board house, and it can be a little frustrating.
They are also in China.
Yes, they're also in China. And so I would just recommend Hackvanna because they are cheap and personable, and I like that guy.
I will note, for as much as we pick on China, there are other studios that you're going to go to, even locally, a local company, that when they produce the board, they send your files to China. They just didn't tell you. It's really hard to escape China. And if you want to, you're going to pay a lot of money for prototyping.
Yep.
Step 9.
Mm-hmm.
Yes.
Why China at this point? What makes it so good?
It's not so much. No, because actually, what the board houses do, I'm sorry if there's any confusion. The board houses, all they do is create this board. They don't it's not pick and placement, it's not assembly. They just give us the board.
Right.
So this is a machine that does all this. There's no reason it couldn't exist in America. The reason why they all exist in China is because all the factories that are doing the assembly are there. And so it's just cheaper to have all these machines in the same place, would be my guess. The only other thing I know is that I don't know how it actually works with export restrictions, but not this board, but there are prototypes you can get for them that are poisonous, basically, that are much cheaper. And I don't think they could make them legally in America.
Right.
Because they don't pass the strict environmental certifications anymore. Yeah.
Step 9. Realize you made mistakes after you sent off the board house and prepared a blue wire.
This happens like 30 minutes after you send the board off.
Yeah.
Or it's 30 minutes after they said, "Yep, it's been made." You are going to make mistakes and have to fix them by hand. It's a pain. Step A.
Step A. Solder the boards.
This is where you just kidnap Tim, you strap him to a table, and feed him liquor, and let him work on boards all night.
Sure.
Always.
See? No. No.
Yep.
Caffeine works just as well. Feed them caffeine, work all night. If you can't I'm not going to read.
You're not going to read what? You're not going to read about yourself in the.
Buy one of our classy Learn How to Solder Boards. Woo! That's sort of one of this project that we were leading up to is sort of an attempt at a Learn to Solder board, teaching a class in soldering in our own hackerspace, Makers Local 256. I wanted a board and wasn't happy with everyone else's, so why not? That was the point of the freedom, was like, I'm going to make my own, and I'm going to be happy with it. That's what it looks like, if big, if you can't see it here. And this is actually the second version of it.
Right, the first version had mistakes.
Had mistakes.
This end to add.
So end to add. Step B. Make sure it works.
And if it doesn't work, you got to go all the way back and look
Right.
at everything. That's happened more times than I would care to admit. Dealing with hardware is far more frustrating than dealing with software. You need a lot more patience. Every mistake adds weeks compared to minutes, I'd say.
Right.
But
Which is one of the reasons to stress the pre-production stage.
it's Moglang,
Moglang?
and so it's correct by definition. I like go-tos. They're cheap. As long as you use them right. It was in Whitespace too. You just got to download the talk and verify.
All right. Any questions?
Jeff.
Jeff. Yes.
There's a tool
Doesn't-
called Icarus,
Icarus.
as well as Gspice is a popular one, and NGSpice. We don't use those because we do not work primarily in analog, and those tools tend to only be very useful, I'd say, for analog circuits. When you're working with digital circuits, you pretty much have strict tolerances that the manufacturer will say, and as long as you operate within them, it works. I also want to say that Tim and I are not double E's.
No, you're right.
And a lot of what we actually do is the data sheets provided by the companies for individual parts are very descriptive in what you need to do to make the device work. And so to some degree, some of this is a lot like working with Legos, and that as long as you obey the rules defined by each of these data sheets, it's just going to work. After you rip your hair out a few times, but
Right.
then it'll just work.
But yeah, and it keeps to the free software stuff with Icarus and Gspice, so it's hooray. Any other questions? Yes. What cheap should be?
So one of the things about the cheapness that's kind of frustrating and interesting is it's actually it's very cheap if you have time. So most of the board houses, like even Seed, if you spend $50 with them, which with Seed will get you 10 boards, they will send the boards to the board house. That takes a little over a week, and then they will basically put them on a tanker, and they will get here in 3 weeks or so. So you're a month for $50. You can spend like an extra $25 with them, and they'll overnight it basically, and so you'll get it within a week and 3 days or so. The guy I like, Hackvanna, you can pay him $50 and they'll be rushed within 24 hours to the board house, and then you can pay another $50 and it'll be shipped. We had one set of boards that we had within a week, from shipping them to him to getting the boards, and it was very nice, but we paid more for rush than we did for the actual boards. I think we paid $50 or $70 for our boards. We got a bunch of them, and then we paid $100 for shipping and expedition.
And slow boat or not, that applies to almost every board house anywhere in the world. That they'll do a rush job. You know, for some companies, it's just going to cost more. If you can wait, a month or so, then yeah, it gets pretty cheap. $5 a board, $2 a board, depending on who you go through and how much you buy. Yeah, quantity starts to matter too.
You can with Hackvanna get one board, but that would be very dumb because you would make a mistake and then you would be another week or 3 weeks out. With most board houses, they limit to 10. So like a Seed, if you buy from them, you're going to get 10 boards, and actually usually get 12 because the way they do it is they take your design and put it on a pallet with a bunch of other people's designs, and then they use up whatever space is extra. And so randomly, different people will get an extra board or an extra 3 boards because they don't want to just waste the space anyways. They're just going to give it to you for free because, hey, free boards, nice. Like we bought 100 of these boards from our guy, and we ended up with an extra 15 or 20. But our guy will actually, he doesn't care. He has an interesting connection with this board house, and he will make you one board if that's what you want. But don't get one board. I get at least 5 of any design you're going to do.
Who am I thinking of?
Dorkbot?
Was Dorkbot, yeah.
Dorkbot does 3s, I think. A minimum of 3. But
they changed their name.
They did?
Yeah.
I don't know.
Open source hardware something.
Are you talking about the SparkFun one? Their board house? Oh, well. Anyways.
Yeah, I'm sure if you look it up, it used to be Dorkbot. They offer a similar service, but it's they'll do 3 boards. No more, no less. You get 3 boards.
Oh. Yeah.
And it's actually even more of a waiting game because they're doing the same thing. You can get it really cheap. It's a great prototype. It's great for a hobbyist, but they're waiting for that panel to fill up so that they'll actually produce a run. So if it takes 8 weeks for that panel to fill up with projects, then it's going to take 8 weeks.
I think they fill up every 10 days or so.
Yeah, everybody's using it,
but
so it's not so bad.
If you hit the bad side of that window,
right.
The other thing that's kind of frustrating that we've dealt with a few times is China has 2 or 3 very long holidays. They just got off of one 2 weeks ago. I think it's the Fall Festival. I can't remember what it's called, but they have just 2 weeks. No one's getting any work done. Like you can call them and say, "I need a board tomorrow," and they'll be like, "No."
Yeah.
2 weeks.
And around Chinese New Year is the other big one.
Yeah.
There's like a month that you don't get anything from.
Yeah. No, but like you cannot deal. They will not send you a board. They were just no one is coming into work.
I don't think they'll reply to email. They're just like, gone. Anyway, any other questions?
Shoot.
Yes. I haven't kept them in my memory, but I know we've done
There's a board house in Mississippi that my former employer does a lot of boards with, and I think it made sense for us to do assembly and boards with them for any run over 10,000 boards.
Right.
I think at 1,000 they were actually pretty cost competitive, and it would be fast to get back and forth with them, but they didn't actually start to outpace them for a long time.
Right. And that's sort of more geared towards production, not development. You could, yeah.
Yes, and you can always do that, right? The output files that this program uses is an industry standard. Everyone takes them and
it's called
pretty easily.
A Gerber.
Yeah. Seed actually does assembly. I know my guy Hackvanna does not. I think Gold Phoenix is another big one.
Yes,
I think they do it as well. And then places in America will do it very well for you, but you have to actually negotiate with them, and it's not something you do for prototypes. I wouldn't recommend anybody do assembling for prototypes. It's just expensive, and it has a turnaround time of its own of a week or 2 weeks of them doing it and then sending you it, and also the whole setup of having when you have a board house do assembly for you, you buy the parts and have them shipped to their factory,
right?
And then they sit with them, and then they guarantee 10%. Overruns or whatever. So 10% of your parts can just be thrown away for you have to eat that because their machines didn't work one day or something like that.
Right.
It's even if they can quote you low numbers, it's still something you have to really think about if it's worthwhile to do if you're going to get that big.
Go ahead.
When you're prototyping breadboard with surface mount parts,
yeah.
do you suck it up and buy the smart boards, or is there
So
some
Blue wire.
we've kind of done it 2 ways for different things. We work with some OLED displays that are very tiny, and at different times we've had just PCBs made with the footprint correctly, and we've worked with it like that.
Pin it out.
We've blue wired them before, and then sometimes you're right. You can just get boards that are quad or TQFP to dip. And SparkFun, actually, that's one of the things that I would recommend buying from SparkFun if it's something difficult for people. They sell a wide variety of boards that just convert TSOP to dip and TQFP to dip and whatnot. Right, it adds up. And once again, it's just the time. The biggest thing that eats all this stuff isn't so much, I think, the money. It's just the time to test things adds up very quickly. We've been working on this one project for over 2 years, and it's something that we've had working in software in the first 3 weeks.
Right.
And it's just, every time we make a mistake, it just adds more time. Very frustrating. Yes, in the back.
Yes. Right.
Mhm.
Right.
Right. And the only problem with some of those, I feel, is that they're very, very proud of their development boards. Right.
Right. Yeah.
Right.
Yep. Exactly. Exactly. So yeah, there are development boards available for a lot of products. If you use those, look for those. Yeah.
Mhm. It's the Bible.
Exactly. And
It's the complete opposite of software documentation. And that everything in it is true, and and it's funny too, you have these product lines that have been out for 10 years, and the addendum for over the life of the product for 10 years is just 2 pages.
Right.
The documentation is 500 pages, all telling of it, and they've only made 2 pages worth of mistakes. And it's the craziest little mistakes, oh, this ADC at this very peak thing that we said it would work, it doesn't. But if you had stayed in the middle where we told you to stay, it would have worked fine.
Right.
And stuff like that. And it is amazing how reliable they are.
Yeah. Any product any chip or something you're thinking about using electronic component, go to the data sheet just right away. Open that up. It tells you so much data. That's what it's for. Yay. Anything else? Any other questions? Comments? Derisive stares? Okay.
Cool.
I guess that's our talk, isn't it?
Yep. Thanks. Thank you.